Hi everyone, my name is Christian Forsberg. I am based out of Grand Forks, North Dakota from the US. I am a DBA candidate at Halford University, and this is a short presentation that I'm giving to fulfill the requirements of the DBA. The title of my dissertation is a business case for AI-driven material review board tools in aerospace manufacturing, enhancing efficiency, reducing costs, and ensuring compliance. This is very important research because it fundamentally changes the game of how we do MRB in aerospace and defense, and it's simply going to become a make or break sort of situation for all aerospace defense companies moving forward, as it saves millions of dollars per year. So what I'm going to talk about, I'm going to do a quick introduction, go over a couple things I found in the literature review. I'm going to talk methodology of how I made this MRB AI tool and what it does. I'm also going to then talk about the business case. Why is it worth it? And then we'll very lightly touch on some case studies, challenges and risks, and future work and trends. So first of all, MRB, for those who may not know, it stands for Material Review Board. It's a critical aerospace manufacturing system, and it has to do with managing your quality. Say you have a multi-million-dollar part, you don't throw it away. If you were to, say, for example, misdrill a hole, you find a way to fix it. However, maybe by fixing it, you don't meet the contractual requirements that that specific part was supposed to be in. And so you end up needing to fulfill a number of contractual requirements to make sure that that exception is valid. And you also have to make sure it's technologically valid. It's not going to make your aircraft crash or anything like that. And so a lot of this kind of stems from the AS 9100 and also from the FAA's Part 21. On the commercial side, at least, military side, the rules are obviously very different. I'm not going to talk too much about that. But a lot of what that looks like is you find an issue, your quality personnel or your inspector is going to write up all the details about that issue. Your engineering team is going to then disposition or otherwise write a step-by-step process for what to do with that nonconformance. And a lot of that is commonly referred to as a tag when it comes to the paperwork. And then the text will carry out those steps, and then everything will get documented, and then that's how you save these million-dollar parts on a regular basis. However, this has been done for years by all these different defense companies, and so there's a lot of data that's kind of sitting there, and it's available for use internally, and that's why, of course, I'm going to be very careful not to talk about anything proprietary, but you use this data and you can plug it into AI to essentially generate your dispositions, or at least come up with a draft to help your engineers do that much quicker. And so then you end up saving about 80% of your engineering time, and that's of course huge because engineers are very expensive. And then also from a manufacturing point of view, you're saving all this time on what's potentially a critical path option. So this is a big deal. It's no surprise to me that this has saved millions of dollars at my company, and it will save millions of dollars at other companies, and it's going to be a big deal. So without further ado, that's kind of the background of what's going on. But of course, this isn't the only application of AI. AI is used for manufacturing quality control. Say your inspectors write up your tag, they need to make sure that that's consistent, and things like that. And you can use AI to help you out with that. You also have AI for root cause analysis. So say you have repetitive nonconformance conditions and you want to kind of find out what needs improvement in your manufacturing process. And so that's also kind of a big deal because AI can go through all of your past data and allow it to come across and like figure out something new that you may have missed by just doing a common fishbone analysis. And so from an economic point of view, this is a big deal, and every company is actively looking into it. Mine is no exception. So in terms of like gaps of current research, I would say that the challenge comes from data. All AI needs good data, and every company is proprietary, there's security clearance requirements, there's a lot of different things that make data not widely accessible. But to those who have it, utilizing that to its furthest degree is going to be a game changer for them. So, in terms of what I did for my company, um, I simply used a NLP layer or a natural language processing layer. So, there's different types of models that are all open source that you can use. And then you have what you would call a machine learning layer, and that is a lot of times just a random forest classifier amongst other things. And then you're going to have a casual AI layer, think like graph neural networks. And then integration, you're going to use things like LoRa, multi GPU, parallel processing, and things like that to be able to actually run this on a company asset, because not every company has access to multi-billion-dollar data centers. So being able to economically compute is going to be a big deal that makes it an economically viable option for your company to look into. And so there's a lot of training and validation that goes into that. There's consistency data, so on and so forth. So from a business case point of view, it's actually really simple. You're going to use a net present value sort of calculation. You're going to look at your return on investment, and I have all those nitty-gritty details kind of outlined in my dissertation already. And of course, you can do things like sensitivity analysis to see when your rate of return is going to be higher or lower given different, say, cost overruns or benefit reductions. But what I'm seeing is that the payback period for integrating this into really any company that does this type of thing is 8 months at worst. At best, it's probably more like 4 months, and that's kind of a big deal because that is not the payback period of time for really any other technological improvement that companies like aerospace and defense industry ones do. And so more case study data in there for sure. Definitely take a look at it. I compared a number of different companies, so things like Boeing, GE, Lockheed Martin, Airbus. These are all really huge ones that would have the data that I'm referring to. And so if you look at a pre-AI and post-AI metrics, so things like defect tracking, RCA accuracy, the amount of savings that you have, they're all huge improvements. We're looking at 35% improvements at worst and more like 80% at best. And maybe your average is roughly around 60. So definitely a huge deal. It's becoming a huge deal at my company as well. Challenges and risks. So I've been talking about data constantly, and that's a big deal. AI is not a magical one-shop solution. You have to be very careful with your data. You have to make sure that proprietary things stay just that. They're proprietary. You have to make sure that your customers' data is also secure. You have to make sure there's no memory leaks. From a technological risk, you can't over rely on AI, and so that's kind of a big thing as well. And there's some reference papers that I found very interesting on that specifically. And so, say your AI has an hallucination, which is somewhat common for AIs, they do that. You need to still have the engineering expertise to be able to handle that. And so, there's a lot of risk mitigation things that you can do for that. I won't get too deep into the details now for the sake of time. As far as future work goes, we're going to be talking about things like AI MRB tools increasingly integrating with digital twins. Think GraphRag or graph retrieval augmented generation. And so now your AI isn't just giving some sort of training set of data and regurgitating what it might look like for a new problem and essentially extrapolating, but rather it's understands context. It knows your specs. It knows your drawings. It knows your program's priority and what it's trying to do. And then it uses that information with what you gave it to actually come up with solutions. And of course, AI is going to get better. Computational efficiency is going to get better. From an industry projection point of view, by 2028, 90% of the aerospace manufacturers are going to be adopting these AI MRB tools because it's a multi-billion-dollar industry. MRB is not cheap. Obviously, it still saves companies money, so they do it, but that's something you want to look into. So with that, again, please take a look at that paper, and if you have any questions, feel free to email me. Thank you.